Well, hello. I hope everyone is doing very well. We are going to start our review for our final exam, and today we are going to be looking at Unit 1. If we recall, Unit 1 had a few different topics in it, and we're going to be looking at the first part of graphing a circle and then writing the equation for a circle. And if we recall that the equation for a circle would be x minus h quantity squared plus y minus k quantity squared equals r squared. And with that, our h comma k is our center, and r equals the radius. So kind of looking at number 1, part A and part B, that our center, we can go x minus 3 equals 0. So our x coordinate of our center is 3. And then we would have y plus 5 equals 0. So y equals negative 5. So our center is 3, negative 5. And we happen to know that r squared is equal to 9. So r is equal to 3. So if we are going to go ahead and graph that, we are going to go over 3, 1, 2, 3, down, 2, 3, 4, 5, make our center, and then we're going to go to up 3, to the right 3, we would go down 3, and then we would also go back 3. And then we would have our points of our circle, and we would draw that too, obviously, the best of our ability. So if we're looking at the second one, so part B, that our center is going to be at 0, comma, and in this case 4, and our radius is also going to be 4, because remember this is r squared. So 0, 4, from here we're going to go up 4, to the right 4, down 4, 1, 2, 3, and to the left 4. And then we would go ahead, and then graph our circle. Hopefully your circles look a little bit better than mine. And next, with that, we're going to be given some information and then asked to write the equations of our circles with our given characteristics. So it says find the equation of a circle with the given characteristics. Very important that our center is 3, negative 2. And the solution point, so first of all, here's really important, center, 3, negative 2. Solution point, negative 2, 1. So this tells us this is h, and that one's k. This is x, and that is y. So we're just going to plug this into the formula for our circle. So x minus h, quantity squared, y minus k, quantity squared equals r squared. And what we're going to be solving for in this case, ladies and gentlemen, is r squared. So we are just going to plug these values in. So we have negative 2 minus 3 quantity squared, 1 minus negative 2 quantity squared equals r squared. So all we did, plug this in for h, k, x, and then y. So now we have negative 5 squared plus 3 squared equals r squared. So 25 plus 9 equals r squared. So 34 equals r squared. But it does say to write the equation, so make sure with this that we are going to be using our center point and then in this case our r squared. So then our equation becomes x minus 3 quantity squared plus y minus negative 2 quantity squared equals 34. And to be a little more mathematical, remember we would say x minus 3 quantity squared plus y plus 2 quantity squared equals 34. And that happens to be our final answer. Part B is a little trickier because we're talking about the endpoints of the diameter. So in order for us to do this, we first must find the center. And we're going to find the center using our midpoint formula. So we're going to go 4 plus 2 divided by 2, comma, 2 plus negative 5 divided by 2. So now our center in this case would be 6 divided by 2, which is 3, comma, and then 2 plus negative 5, so that would be negative 3 over 2. So this is very important because now here is our h and k. And we have to use our h and k because that's our center. And then now that is our solution point. So now we're going to go ahead and use our formula that we just had above. And this becomes x, so 4 minus 3 quantity squared, plus y, so 2 minus negative 3 halves quantity squared equals r squared. So now we have 1 squared plus, and in this case this is going to be 7 halves, I believe. Let me double check. So we're going to go ahead and go 2 minus negative 3 halves. So 7 halves, just double checking. Quantity squared equals r squared. So 1 plus 49 fourths equals r squared. So in this case, r squared equals 53 fourths. So now we're going to go ahead and use our center and use that r squared to write our final equation. And then that becomes x minus 3 quantity squared plus y minus negative 3 halves, so y plus 3 halves quantity squared, and that is going to then be equal to 53 fourths. Oops, 53 fourths. So a little messy there, but not too bad. So that was our first thing that we did in Unit 1. The last two things that happened to be on the final review are going to be some of our different inequalities that we looked at. So if we look at A, B, C, and D, A and B are done very similarly. C and D then are the absolute value inequalities. So let's go ahead and look at solution A. So right now we have x minus 8 divided by x plus 5 is greater than or equal to 0. And if we recall, we're going to kind of look at a number line as well. The first thing that we have to find are the critical values. And that's going to be found by setting each of those equal to 0, except there's going to be something special with that x minus 5. So first of all, we have x minus 8 equals 0, and x minus 5 cannot equal 0, because remember, the denominator cannot be equal to 0. So x equals 8, and x cannot equal 5. So we're going to go ahead and put those on our number line. So we have 5 and 8. And then we're going to look at the sign and have to decide, are these values included or not included? So first of all, since 8 was equal and it's in the numerator, it's going to be included because it's greater than or equal to. Very important, however, with this 5, it is not included. So it has an open circle. And now notice our number line is divided into 1, 2, 3 different parts. So now we're going to set up our intervals. And then we're going to do a kind of a little test value, yes or no, do they work? So our first interval goes from negative infinity to 5. And notice that 5 is not included. Our second interval is from 5 to 8. That 8 is included. And our last interval is from 8 to positive infinity. And that 8 is also included. As I've mentioned, now we're going to just pick a number somewhere in there and plug it in and decide yes or no, does it make this inequality true? So pick a number between negative infinity and 5. I like to work with 0, so I want to know is 0 minus 8 over 0 minus 5 greater than or equal to 0? So I finally want to know is negative 8 over negative 5 greater than or equal to 0? So that would be 8/5 greater than or equal to 0. And hopefully you would decide that, yes, that one works. So now pick a number between 5 and 8, not including 5, not including 8. So let's go ahead and let's say 6. So now I want to know is 6 minus 8 over 6 minus 5 greater than or equal to 0. So negative 2 over 1, is that greater than or equal to 0? That is no. And if we remember, these should potentially alternate. So if this one's yes, this next one's no. So our last one should be yes. So number between 8 and positive infinity, let's just go with 9. So it's 9 minus 8 over 9 minus 5 greater than or equal to 0. So 1/4, is that greater than or equal to 0? And our answer happens to be yes. So that means that this is part of our solution and this is our solution. So if we're going to graph that, we would go up here and our arrows go that way and this way. But sometimes we wanted our answer in interval notation, so that goes from negative infinity to negative 5 union 8 to positive infinity. So then there is our final answer. And kind of looking at letter B, same type of thing is going to hold true. We have x squared plus 8x plus 15 is less than okay, and looking at this, first thing we're going to do is go ahead and factor these. So yay, because we know how much we love to factor because we're going to find our critical values. So what are two numbers multiplied together, that's 15, that add to be 8? And hopefully we realize that would be x plus 5, x plus 3. So then our critical values, we've got x plus 5 equals 0, x plus 3 equals 0. So x equals -5 and x equals -3. So just like before, we're going to go ahead and put those on our number line. -5, -3. And we're going to set up our intervals. So now our interval goes from -infinity to -5. And notice now, looking at this, since it's just less than, that is not included. So then we're going to go from -5 to -3, and then -3 to positive infinity. And we are now going to pick a number in that interval. Once again, you can start wherever you want, and remember they should alternate. So we know they're not going to be included, so we've got open circles. So finally, let's go -6. So I want to know, is -6 squared plus 8 times -6 plus 15, is that less than 0? And we can go ahead and use our calculator if we want to. So -6 squared plus 8 times -6. Let me go do this again. Clear. -6 squared plus 8 times -6 plus 15. So I want to know, is 3 less than 0? So that happens to be no. As we know, they should alternate, so our next answer should be yes. So a number between -5 and -3. Let's look at -4. So -4 squared plus 8 times -4 plus 15, is that less than 0? So -4 squared plus 8 times -4 plus 15. So is -1 less than 0? Yes. And then last but not least, a number between -3 and positive infinity. I'm going to go ahead and pick my favorite number, 0. So is 0 squared plus 8 times 0 plus 15 less than 0? And we would find out that's going to be no, because that ends up being 15. So therefore our final answer is just that interval. So our graph is going to just be that, looking like that. And then our answer in interval notation is -5, -3. And the last little bit from Unit 1, ladies and gentlemen, is our absolute value. And if we recall, absolute value has two solutions. So the first thing we're going to do, we've got 2x plus the absolute value of 2x plus 3 less than or equal to 15. We are always going to isolate that absolute value first. And as we notice, that happens to already be by itself. So from here, we're going to set up two inequalities. So we have 2x plus 3 is less than or equal to 15. Subtract 3 from both sides. So 2x is less than or equal to 12. Divide by 2. So x is less than or equal to 6. And then our second one, we would do the opposite of our quantity. 2x plus 3 is less than or equal to 15. go ahead and distribute that little negative. So negative 2x minus 3 is less than or equal to 15. Add 3 to both sides. Negative 2x is less than or equal to 18. Divide by negative 2. So x is greater than or equal to negative 9, because don't forget to flip that inequality symbol when we divide. Looking on a number line, so we have negative 9 and 6. X is less than or equal to negative 9, so our graph looks like so. Greater than or oops, I just did that backwards. Looking at that, so don't disregard. We do that in a different color. So less than or equal to 6, close circle, going this way. Greater than or equal to negative 9, close circle, going that way. So notice they happen to meet in the middle, and I apologize for that. And so then our final answer is from negative 9 to 6. And there is our lovely little brackets. And that's our interval notation. And I'm not going to work out the last one because I'm sure you're getting tired of watching this. But ultimately, just to kind of get us started, we have to isolate that piece first. So the first thing we're going to do is go ahead and add 7. So 3 times the absolute value, 2x plus 5, is greater than or equal to 3. Still getting our absolute value isolated. Not quite done yet. Divide both sides by 3. So we have the absolute value, 2x plus 5, is greater than or equal to 1. Once that absolute value is isolated, is now when we're going to go ahead and set up both of our inequalities. I'll show that last step. So then our first inequality is 2x plus 5 is greater than or equal to 1. Our second inequality is the opposite of 2x plus 5 is greater than or equal to 1. And then we would go through and solve both of those. That is it for this lesson. So next time we will be reviewing Unit 2. Have a great day. Bye-bye.